again because they had a hardware failure. It wasn't their fault that something we gave them broke, basically. So, can you explain exactly what happened? What exactly broke?
So the left motor on the robot's left motor wasn't turning. So we were trying to apply like a counter torque to it to see whether or not it would respond, and it would just stop. So we got a multimeter and we tested the voltage and the current, and then finally had a replacement motor that we just replaced it with. So hopefully it won't turn around in circles, and we'll see now.
So your robot looks a little unusual because it has that big motor sticking out the front. Can you maybe explain what that is?
So Darther suggested that we take this motor. The guy on All Electronics who actually reviewed the motor said that it was so powerful that he used 2 of them to power the drive system for a 120-pound R2-D2 robot that he built. So it's a pretty strong robot. If you take apart a windshield wiper, you'll find a very similar motor, as well as those automatic seatbelt things that you have in cars that keep you safe. The same sort of motor there. So it's a very powerful motor.
So it's a little different than a normal motor because the shaft comes out the side, right?
Yeah, it's right.
So it knows that it has a ball, right?
Yeah, so like I said earlier, Karen's team, Shahara, every time the robot changes state to capture ball and goes towards the ball, it assumes that it captures the ball. And so the next state that it'll go into is wander. Whenever it sees a goal, when it says that, oh, I have a ball and I see a goal, then it will attempt to score.
So it looks like it put that ball on the porch.
It appears to be so.
So can you talk about the sensors that you have on your remote?
So we used the USB optical mouse as well as 2 IRs that are mounted on the servos that are on front. The optical mouse was so the optical mouse was actually really easy to implement. USB mice communicate through the same sort of communication protocol that PS2 mice communicate with. So when you plug it in, through the wonders of Linux, you can just sort of take off directly these little differential segments that the mouse reports. So it can tell you, it spits out just counts. So whenever you just move the mouse rapidly, then our program will say, well, you've moved so many counts, and then it'll go back to 0. And so you can sort of sum all of these counts over to determine how far you've gone with reasonable accuracy. The clever idea of sort of interacting with the mouse as easily as it was actually suggested by Ryan Hunter on Team 12. So, yeah.
One of the nice things about Maslab is how close the teams become to each other, and they help each other out a lot, which I think is fairly unusual. So what is your robot doing right now?
So it's probably in a wall following mode, I don't see any balls around it, so it's probably not tracking balls, so it's probably wall following or wandering. It actually alternates between just a regular wandering mode that is dependent on its IR sensors, as well as just like a wall following mode that is also just dependent on the IR sensors.
So the sensors you have IRs. Do you have any bump sensors?
We don't have a bump sensor, so what happens is whenever the robot gets stuck, the mouse will stop reporting differential segments, it will stop moving. So if after a certain sort of number of iterations it detects that there's still a stall, then it'll just go into an escape state and just move away.
So how do you keep from, I know the mouse hangs down from underneath the robot, how do you keep that from getting stuck on the folds in the carpet?
The mouse? Oh, so the mouse has this really nice suspension. The top of this aluminum plate is sort of bolted to the aluminum cage that's on the bottom. Then there's one bolt that goes towards that connects to the front of the mouse, as well as another bolt that connects to the back of the mouse, but the back of the mouse the bolt is connected to a spring, and so it allows the mouse to sort of hover up and down based on the spring.
Can you talk a little bit about your roller, maybe the design of that?
Yeah, so we originally had a soft compressible. Foam for our roller, but that didn't seem to be working so well. We ultimately just a couple days before the competition, I made two of these. I